This is a video for Chapter 2 for Statistics 252. The subject here is organizing the data into classes and drawing some graphs. For the first problem in this homework, you're given a data set and you have to organize it into classes, then find the class boundaries, the midpoints, tally it up, and then find the frequencies. You don't have to draw any graphs for this one. Okay, so what we're trying to do here is find the classes, set up the classes for this data. Let me get a pencil here. Okay, the first thing you do is find the smallest value and the largest value. And the smallest value is like 3.1, and the largest value is 3.87. So here I'm going to mark these again. If you remember from the lectures, the book or the written lectures on Blackboard, there's certain attributes that the classes must have, and this is what we're trying to do, is find the classes for them. The classes are not just the data divided up, they're like containers that you're going to put the data in, and they have to be nice, even, round numbers, nothing with a whole bunch of decimal points. It's not an exacting thing, it's a container to stick these numbers in to organize them. Right? The classes have to be exhaustive, meaning they're going to have to include all the numbers, the smallest number up to the greatest number. They have to be continuous, means you're going to have no gaps in them. Just because you have no data points in one of the classes doesn't mean you can skip over it. They need to be of equal width, and we'll review in a second here how to calculate the width of the classes, and there should be somewhere between 5 and 12, sort of a reasonable number of classes. If you have too many, you might as well just work with the data itself. If you have too few, that doesn't, you'll miss any miss the information that the data is giving you. What I'm going to choose here is some classes. Let's just go like this. Let's have them be of width 0.1. So I need to include a 0.1 here. I'm going to start at 3.0. And the width is the difference between the first numbers of each class. So this will be 3.1. No, let's do it. I'm going to do it 2. Okay, so this would be better. 3.2. Then this would be 3.4. 3.6. 3.8. Okay, so I just wrote down the beginning numbers of the classes. If I did the 3.1, I'd end up with a 3.09 for the last, so it's just too confusing. And you want it to be round. This is the thing you're going to graph. You need to be able to see these visually. Okay, so you see the width here is 0.2. Now the lower or the upper boundary of each class is not the same as the lower boundary of the previous class. It's right before it, so we'll go 3.1. 3.2 is to go to 3.3. 4 is going to go to 3.5. 3.6. 7. Can't count. And 3.9. Okay, there's your classes. Now the class boundaries are bigger than the classes. Their edges match up, and those are to catch any numbers that don't fall exactly, that don't end exactly at 3.0 and 3.1. Example up here we have a 3.12. Well, where does that go? And so this is where we set up the boundaries. So, and the boundary has one more decimal point, one more decimal place than the class itself. So 3.0, we'd have to start at 2.95 for the boundary, and then it would end at 3.15. So it's just slightly bigger than the class. This is 3.15. I should do some rounding here. 3.35, and continue like that. 3.35, and then 3.55. 55, and now I'm going to 3.75, and this one 3.75 up to 3.95. The midpoint of the class is, well, just go right between in the class. Don't worry about the boundary. Well, actually, it'll come out okay. The same 2. All right, what's between 3.0 and 3.1? You can just add them up and divide by 2 if you aren't sure. is 3.05. There's a midpoint there. 3.25. And again, if you have some boundaries you're not sure of, to find a midpoint, take the lowest number, or take the highest number, and divide by 2. You do that on the calculator. 3.45, etc. There's 3.65 and 3.85. Now that you have the classes set up, you go through and you make a tally. It means you look through here, and it's easier to do in a tally than to try to count and try to figure out if you've counted them up. Just make those hash marks. Okay, 3.14, where's that going to go? Well, look at the boundary. You can see where that goes. It goes right here. 3.20 is going to go here. I'm just going down this list. 3.20, another one here. 3.52, 52 goes in this group. 3.42 also goes in this group. 3.33, we'll go back down here. 3.16. 16 is actually going to get bumped up to the second class. Alright, so just continue with this data all the way through. For example, here's that. Oh, I wanted to show you that there's not going to be anything in this data set between the 3.55, the 3.6, and the 3.7. There's going to be nothing here, but that's okay. You still include that class, even though there's nothing there. When you're done with all this, you add up all these hash marks, and you get a total here, which I'll call N. That's a good check. Then for frequency, you just go over here and change these hash marks into numbers. For example, if that was all that was in this class is 4. If all that's in this class, it's 0. You don't have to divide by the N, but when you add those up, you better have the same N in both columns. So again, to review, take your lowest number, take your highest number, make sure you're going to include those numbers. Then make nice rounded classes. They're containers. They're bigger than the numbers. You don't have to just divide the numbers by 5 and then those are the boundaries. It would be too confusing and also very, very hard to graph. Remember that the lowest number, the lowest number for this class is not the same as the upper number for the previous class. That difference is taken care of in the boundaries. The midpoints, lowest number plus highest number divided by 2, or you can just eyeball it. Tally marks, it's easy when you want to compute frequency. It's easier just to go down the data, this one, this one, this one, this one, and make the tally marks, and then compute the frequency. If you go through and try to pick out the ones that would be in this class, and this class, and this class, you can do that if you want, but it's much easier to just make the little hash marks and count them up. Here's the second problem for this homework, and it's similar, but you're going to do a histogram when you're done, and also you're going to compute the relative frequency. The frequency was just the count in numbers. Now we'll compute the relative frequency, which is it's handier than the other. Okay, it says organize the data into 6 classes starting with 0. So there's a hint there, so you don't have to spend too much time trying to figure this out. So it's going to start with 0. There's nothing less than 0, so you're fine there for data points. And the maximum value is 597. So if you set the classes up by hundreds, again, counting your fingers if you need to, so you'd start with 0, 100, 200, 300, 400, 500, and 500 would go from 500 to 599. That would work. So here I am, if I can find the pencil. So I start with 0 to 99, then the 100. See, the width of the class is going to be 100. It's not 99, it's 100. You can fill this in. 400, 500, whoops. And the maximum here is 599, and that will give you that data point. And you can fill in the rest of that. Then for the tally, you go through and do the same thing you did before. Here I didn't bother with the class boundaries once you understand what's going on. So 248, obviously going to go here. 348 is going to go here. 74 is here. 514 is up here. And you work through all that, adding up, putting all your tally marks. Then add up the frequency, which means take these numbers and turn them into integers. I change these around so I can never remember. 1, 2, 3. Looks like there's going to be 8 here. and you add up all the data here and you get some value for n. To find the relative frequency, you take the frequency divided by the total number. I'm going to go ahead and work this out so we can see what we've got here. So we've done the first four numbers. 597 will go down here, 270 here, 71, 226 is here, 41, 39, 366. That's a 3, by the way. Just didn't make it. Okay, 73, 241, 46, 34, 149. Got a point here. 68, 73, 63, 65, that number was wrong, 109, 598, oh, I missed that one, 598 was the max, but we're still okay, 278, 69, 27. Okay, there's nothing in the 400s, but that's fine. So this is 13. There's 2 here, 5, 2, 0, and 3. The total numbers, you can add that up, it's 25. Now for the relative frequency, you take the frequency, in this case the 13, and you divide by 25. Here you take the 2 divided by 25. And this is the 5 divided by 25. And you continue like that, another 2 divided by 25. This is 0 divided by 25, which is 0, and 3 divided by 25. Then you can go to your calculator and divide 13 by 25, and you get a fraction. In this case, 0.52. Now to turn that into a percent, you move the decimal point 2 places over, 2 places to the right, and that's the same as 52%. We usually record the relative frequency in percent. People are used to talking in percent. Do the same for all the other numbers. When you add up the relative frequencies, you don't get 25. That's the number you have. The total should be 100 or close to it. It should be 100%, or if you work with the decimal, it should be 1. Then to make the histogram, you're given a graph. I changed these homework videos around a little bit, so I'm not doing exactly the homework, but really, really close. That's why this says number of cities. What that data was before was for murders in 25 selected cities. It was some data from the government. All right, to make a histogram, in the first graphs that I give you, I already have most of the numbers on the vertical and horizontal axis in place. And the last one, I don't, and you have to put it in, but we're just sort of working up to that. Okay, you'll see here, this is labeled, and the important tick marks are labeled. These are going to make the classes, right? In this case, for the 0 to 100, it was 13, so you've got some tick marks here. This is also labeled with what it is, and it has numbers along the axis. Okay, so it was 13. Let's see, I think I've got a straight line here. So this would be 100, and it, I guess 13's, well, out here. Okay, there's a histogram. Now for the 200, I think the next one was 2. Maybe about like that. I don't want you to do it with the pencil. Next one I believe was 5, so here's a 5. Okay. Oops. And okay, so now I'll answer the big question. And then here was a 0, of course. Okay, big question is, why don't I just put all these numbers into Excel, punch a button, and have the graph come out? And the reason for that, okay, this is my philosophy here. The reason for that is that you don't learn anything. You learn to punch a number, and you learn to become a technician of Excel. If you want to do that, you can take various courses that show you how to do it, just Microsoft courses, and get Microsoft certificates. This, I want you to be able to know how to do this. What happens when Excel changes? What happens when you go to a company and they say, we don't use Excel, we use some other program, we're using OpenOffice, we're using this. And also, you don't really understand something until you've taken it in your hands and you've done it. And you might say, well, that's true for machining or for drawing or something like that, but how could it be true for math? And it is also true for math. You take that pencil, put that pencil on the paper, write down the points. There's a surprising amount of learning that takes place from the fingers to the head, as well as the eyes to the head and the ears to the head. So that's why I want you to do it. The number sets that I give you are small. You can handle them by hand. Use a calculator to get some of your numbers, but I want you to actually draw them. Until you actually draw them and wrestle with them, you don't know. And then I'd like you to go on from here, and if you're interested in this subject, I want you to become a developer for Excel. And that's why I'm giving you this kind of background, and that's why just punching numbers into Excel isn't good enough. If you punch a number into Excel and attach that at homework, it doesn't count. If you use Excel or some other program to check your homework, okay, fine, that's great, but I want to see hand-drawn graphs. And if you use a ruler, they're good enough. Okay, so that's all I have to say on that subject.